Hello everyone, this is seventh part of this chapter IO organization and your topic is now programmed input output. You already know what is programmed data transfer. Still I repeat, programmed data transfer is that in which IO device and main memory cannot interact with each other without the intervention of CPU. IO device has to send data to CPU. CPU will convey that data to memory and vice versa. So programmed input output is that mechanism in which IO device, that means input output device, will transfer its data to CPU and CPU in turn will transfer that data to memory. Here I am saying that IO device transfers its data to CPU, but it is not that simple. There must be one intermediating device who will be responsible for transfer of data between CPU and IO device, and that intermediating device is nothing but an interface. Let's see how is the diagram, or what is the diagram. See, this is the diagram for programmed input output. Here, IO device is such a device who transfers 1 byte of data at a time, right? And you can recognize this kind of data transfer, I think, between IO device and the interface. This is interface. Asynchronous data transfer happens, and it is which kind of asynchronous data transfer? Is it stroke pulse method or handshaking method? Since there is a two-way communication, so it is obviously a handshaking method. Now, is it source initiated or destination initiated? Since IO device transfers its data to CPU via interface, but IO device is the source here. So this is source unit and it is initiating the data transfer. So it is source initiated handshaking asynchronous data transfer between IO device and interface. Here IO device is the source unit and interface is the destination unit. So according to that rule, IO device, that is the source unit, initiates its data transfer by sending its data into data bus. Here the name is different, but the function is same as data bus, and this is same as IO bus, right? So IO unit is initiating its data transfer by sending its IO data into IO bus. Okay. After that, according to the rule of source initiated handshaking method, IO device pokes interface that I have sent you data, please accept it, by sending a data valid signal, right? After getting this data valid signal, interface does what? Interface accepts this data, and where does it keep? Interface keeps this 1 byte of data into this data register. Okay. After that, I'll be saying you about this status register and if. After that, interface responds the IO device by sending this data accepted signal. You are familiar with this transmission, right? Here the status register actually shows the condition or situation of this data register. This is a one flag, F is a flag, right? And it can take one of the two values, either 0 or 1. Now, if data register is empty, the value of F is 0. If it is empty, F is 0. If data register is full, that means it has 1 byte of data in it, data register, then the flag's value is 1. Okay? And CPU keeps on reading this status register or the value of this flag continuously, whether data register has 1 byte of data in it or not. Now it's CPU's turn to transfer this one byte of data from IO device to memory, main memory. How CPU perform this? See, first of all, CPU checks the status register, that means reads the status register, the value of the flag. If it is 0, then CPU keeps on reading this status register. Okay, if this value of f is 1, then CPU reads this 1 byte of data to memory. This is how CPU transfers this data to memory. Now, one more thing to do is either CPU or interface after reading this data changes the value of f to 0, because now data register is empty after reading, right? This is how IO device's data is transferred to memory via CPU. Okay, what CPU does with interface has to be explained via one flowchart. See how to do it. CPU reads the status register. Next, what? It checks the flag bit in status register. So we can write it check flag bit. Now I'll draw a diamond because it is a condition check, value of f or flag. If flag's value is 0, that means data register is empty. So CPU has to again read this status register. If flag's value is 1, then what CPU does? It reads the data register. Right. After that, CPU checks whether the operation is complete or not. Operation complete means suppose IO device has 5 bytes of data to transfer. So in this turn, only 1 byte of data is transferred. So 4 bytes of data is still remaining to be transferred, right? So that's why I'm checking it. If yes, finish it or continue with program, whatever you write. If no, then CPU has to read the status register again. Got it? Finished.